This is your Unit 2 review videos. First problem, we're just sketching the graph of a line. Now this would be great if they gave it to us in slope-intercept form because that's how we graph, but they didn't. They gave it to us in standard form. So we have to solve it and put it in slope-intercept. That is 3x minus 5y equals negative 10. Slope-intercept, the whole goal is to have y all by itself. So again, we're beginning the problem with our goal in mind. Okay? So I'm going to leave y on the left side right where it is, and I'm going to subtract 3x from both sides. Now, for convenience sake, you actually could have started this problem by adding 5y, but I have so many students on a daily basis that are so stuck with having to have y on the left side. They don't do well if they move y over, so I've just gone ahead and left it on the left-hand side. After I'm done subtracting and moving the x's over to the right-hand side, I rewrite it with the negative 3x in front. That way it's looking like our formula here. And speaking of looking like our formula, our final step here is to divide both sides by negative 5. That becomes a big 1. Okay? They cancel out, leaving a 1y or just a y. And on the right-hand side, negative over negative. 3 doesn't really divide into 5 evenly. We're going to leave that as a fraction because it's slope. But negative and negative do cancel out and become a positive 3/5. That's this division. We also have to do a division there, and that becomes a positive 2. So we're looking for an equation that starts at 0, 2. That'd be the first thing I look at. I've got 2 of them. Looks like B and C both start at positive 2. So I'm looking for the one with the positive 3/5 slope. B is the only one that's increasing that goes through that, so it must be that one. Let's double check. Up 3, we'll notice it's scaled by 2, so 1, 2, 3 over 5. 1, 2, 3, 4, 5. Spot on. For number 2, it says write the equation of each line. Okay, so this time we're given the graphs, we have to find the equations. Number 2 is very easy. Number 3, you'd think, because it looks so similar, you'd think, oh, number 3, that was really easy too. But it's not nearly as easy. So let's talk about number 2 first, though. There's 2 ways to do it. 1, you can do this in the graphing calculator, okay? However, when you start graphing these equations, they're never going to look quite like this exactly because of the scaling. So if you do go to start graphing these, my advice is to pay very special attention to where it's crossing the axes, the x and the y axis. So this first one, if we want to do it in the calculator, negative 5x minus 1, and we graph it. Okay? Well, this one didn't work. It was clearly decreasing. And that leads me into the other way to do this problem. You can just know facts about graphs. First off, this line is going uphill. That means it should have a positive slope. That means the number m in front of x needs to be positive. Well, that would have gotten rid of a, and that would have gotten rid of b. So instead of just graphing all these and wading through all the trash ones, let's start using our heads a little bit. We know it has to have a positive slope, and now I look at these last 2 that I have left. Well, both of them start at negative 1, right where this one starts. That would have been another defining characteristic to help us weed out some of them. Okay? So basically we're down to either it has a slope of 1 or a slope of 5. So let's see, this one looks like it's going up 1 over 1, up 1 over 1, up 1 over 1. I'm thinking it's going to be C. What would up 5 look like? 1, 2, 3, 4, 5, and then over 1, that'd be a much, much steeper line. Okay, so again, like I showed you with option A, you can go through and just type all these in one by one and find the right one. Or if you know a little bit of something about y equals mx plus b, then you can do it that way. Okay. Number 3 is a very long problem. Okay. The shortest way to do it is probably by knowing all how your y-intercepts and x-intercepts all work. Okay. But a lot of people don't do that very well. So their way of doing it might have to be solving and getting everything in slope-intercept form. All right. Now, what do I mean by doing it the easy way, though? I noticed that my x-intercept is 3, 0. That means if I look down here at these graphs, I could plug in a 0 for the y, and I should get 3x, 3 equaling x. Let's see which ones work for that. Plug in a 0 for the y here, that makes it disappear. I would have to divide by 3. That's not going to give me the correct x-intercept, so A is out. Okay? If I plug in a 0 here for y, it makes it disappear. And again, I'm going to get a weird fraction, meaning B is out. Because it's just not matching up, guys. It's the correct x-intercept is not showing up when I test the equation. Well, let's try this one. When I plug in a 0 for my y, it makes that disappear, just, because it'd be x plus 0, okay? And I get x equals 3. Okay, well, that one looks like it checked out. So if it checked out, you can either move on to the next one, which you see would fail, or you can test your y-intercept. My y-intercept is at 0, 3. Very, very similar, opposite placements. Meaning if I plug in a 0 for my x, I should get that y equals 3. Let's double check. This time I'm plugging in a 0 for my x, so it goes away. I'm left with y equals 3, meaning 0, 3. So both ways that one checked out. Alternate methods, you could solve all of these for y and see which one, when you graphed it, gave you that equation. It's going to take longer. It's not wrong. It's just going to take longer. Number 4 is supposed to actually have multiple choice sections on there. This PDF version that I have doesn't have them. Shouldn't be the end of the world. And it's a good idea to be able to work this out by hand anyways. From the formula sheet, we know that m equals y2 minus y1 over x2 minus x1. That's a really fancy way, guys, of just doing rise over run, okay? Basically, it's saying, hey, what's the difference between these two y values? That's the difference in the rise, divided by the difference in my x values, which is the run, okay? But it plugs in like this, -1, and then a minus sign, and then a -16. Well, you can put it in the calculator that way, but really, you should know that 2 negatives right there make a positive. Minus a negative is actually just add. We're going to divide that by x2, which is -18, minus x1, which is just a 20. Okay, work the math out. It's going to be a positive 15 on the top. It's going to be a -38 on the bottom, meaning I get -15/38 as my slope. Let's double check that using the calculator. It was -1 plus 16 on top. Alpha y equals enter. -1. Let's actually, you know what? Instead of doing plus 16, let's just put it in the calculator like it was. Minus a -15 or 16. Okay? That's that double negative. Now, we turned it to a positive, but let's say you forgot about that rule. Well, let's see how the calculator does it. Then it was -18 minus 20. And what do you know? The calculator, it solved this for us. It knew that this was supposed to be a plus sign, and it changed it, but it still comes out to be a -15/38, just like we got. For number 5, write the slope-intercept form of the equation of each line. There are more of these on the test than the others because it tends to be the most useful, most important one. Number 5 is your review about vertical and horizontal lines. A vertical line should always be y equals a number. Specifically this vertical, or horizontal. A horizontal line should always be y equals a number, not a vertical. So I'm getting ahead of myself thinking about the next one. Okay? So horizontal lines are always y equals a number, and they have 0 slope. You can remember that because the z in 0 has horizontal lines in it. Alternatively, a vertical line is always x equals a number, okay? And it has no slope. I prefer to call it undefined slope, and you can remember that though, because no has vertical lines in it. Well, it would be vertical if I didn't slant my letter in to the side a little bit, but you get the gist. X equals a number. Also, y equal a number. Okay, obviously we go down to -3 and make a horizontal line, but that one we can graph in the calculator. So for this problem in particular, let's say you forget all those little rules. Well, y equals -3. Throw it in the graph, and you see that, oh, that matches number 5's graph perfectly. Okay? Number 6, again, the same directions are still applying. On number 5, we didn't really need them that much, but here on number 6, we have to be able to go back and look at the directions. We want slope-intercept, which is y equals mx plus b, and again, the goal